Now we will discuss standard free energy change of reaction. Standard free energy change of reaction and equilibrium constant. Simply the relationship between delta G and as well as K, relation between these two. What is standard free energy change, sir? It is a thermodynamic quantity. If you take in thermodynamics general form, here Gibbs free energy or simply standard free energy change. What is the definition of G, sir? Simply, it is a thermodynamic property. The thermodynamic property that measures maximum amount of energy is available for work. Maximum amount of energy is available to perform the maximum amount of energy. The maximum amount of energy is available, or the maximum amount of energy available to perform work in a system at a constant temperature and as well as a pressure, at a constant temperature and pressure, is called standard free energy, or it is also called Gibbs free energy. Okay, the mathematical expression of this formula H minus Ts, where H is a Gibbs free energy. Sorry, this is enthalpy. T, absolute temperature. S, entropy. G indicates standard free energy or Gibbs free energy. We cannot measure in this term Gibbs free energy or standard free energy. We can measure change of Gibbs energy. That is, change means delta G is equal to delta H minus T into delta S. This is a standard Gibbs free energy change equation. Delta G is equal to delta H minus T into delta S. Okay, now the standard form of thermodynamics here, that is, we can observe. Now I am taking here delta G naught is equal to delta H naught minus T delta S naught. This naught, which indicates standard free energy change, standard change in enthalpy. Delta S naught, standard change of entropy. T, absolute temperature. This is the mathematical expression of standard free energy change. Now, here some conditions are there. What are the conditions or cases? If delta G naught is equal to 0, then Kp is equal to Kc or is equal to Qc. That is first condition. If you take second case, If delta G naught is less than 0, K value always greater than 1. If delta G naught is less than, means negative. You take here delta G naught less than means here. Now I am taking negative values. K is always greater than 1. Then the values always here. Then the reaction is takes place forward direction. Forward reaction. If you take second condition, third one, if delta G naught value is positive value, K is always less than 1. Means here forward direction means product predominant over the reactants. Here backward direction or backward reaction takes place. Backward reaction means the reactants predominant over the products. Here products domination is more, here reactant domination is more. This once again repeat here. If delta G naught is equal to negative greater than 1, K is greater than 1, forward reaction thermodynamically at a unit concentration or unit partial pressure, the pressure of products exceeded partial pressure of reactant, that is the products are favorable in forward direction. Here the reactants are favorable, the backward direction takes place. This is information about what is the standard Gibbs free energy state. We will continue.